Okay, so we're doing adding and subtracting rational functions. So we need to simplify this function here. Okay, what we want to realize, okay, if this was in factor form, this would probably look like this with a bracket around it. But what we have down here is a quadratic, so we actually have to factor that guy. Okay, so when we go to factor it, I'm just going to do it real quickly. That's x squared minus 3x minus 4. Can you get that, Katrine? Because the a value is only 1, it's really easy. I just need two numbers that multiply to -4 and add to -3.
4 and 1.
4 and 1. So
-4 and 1.
x minus 4, just pick it up, Katrine, and
Hello?
x plus 1.
Mm-hmm.
Right?
Hello?
So this bracket now becomes that.
Hi.
So
Yeah.
3, and we have
What?
x plus 1,
Oh,
and then
you
4.
picked up the phone. Mike told me to pick up the phone. I
We
don't
have
know.
x minus 4, and x plus 1. Okay, so here what needs to happen is, because this is an addition of two fractions, you got to think back to old fraction rules. So I'm going to make a question up. If I have 2 over 3 plus 1 over 2, I can't add these unless what's the same? Denominator, okay? So what's a common denominator here?
6.
6. So in order to make 3 6, what do I got to do?
Multiply by 2.
Yeah, but do I only do the bottom?
No, you did
I
not.
do the top also. So that gives me 4 over 6. And what about this one? By 3, 3. So we get 3 over 6, right? So our final answer would be 7 over 6 for fractions. Well, because our denominator here, this one's pretty straightforward. This one's already x plus 1, right? This one is x plus 1 times x minus 4. Well, this is simple. I actually don't have to multiply this one by any because it already has an x1 involved in it. So all I really have to do is this guy here, this x minus 4, I have to multiply the bottom by x minus 4 and the top by x minus 4. Maybe you were saying that.
Why do you call it this unit?
Okay, so when we do that, we're going to be left with 3 times x minus 4 divided by x plus 1 and x minus 4, and then plus 4 over x minus 4 and x plus 1. Well, because the denominators are the same, we can write this as just one fraction, x plus 1, x minus 4, and this becomes 3x minus 4 plus 4. Well, I can simplify that top. If I distribute this 3, I'm just going to write it over here. That becomes 3x minus 12 plus 4, which is going to become 3x minus 8, right? So our next line would read 3x minus 8 divided by x plus 1, x minus 4. I can't really factor that top there, that's fine. So this is the point where we would find restrictions now. Neither of these bottoms can be equal to 0. I know that x plus 1 cannot be 0, and x minus 4 cannot be 0. So when I move 1 over, x cannot be negative 1, and x cannot be positive 4. Okay? Now, sometimes in these expressions, let's just say it so happens we had something like, we're just going to add this to the bottom, okay? So this is not part of it. At this point, we're done with the question. But let's say we added this to the question, okay? Well, because those are there, we can take them out, right? They cancel out. But you must do restrictions before that, because that is still a restriction even though this thing cancels out.
Yeah.
Okay, so just keep that in mind if you're to do it that way. Let's take that out because it's not really an answer. Okay?
What?
So that's it. That's the whole question. You've simplified it and you've stated your restrictions. That's all there was to it. The key was making sure the denominators were the same, because when you add and subtract fractions, which is rational functions, the denominator has to be the same, just like old school fraction rules.